Hello students, in the first video lecture we discussed about the laws of the Newton's law of gravitation, Kepler's law of the planetary motion and variation of the gravity on the surface of earth with the altitude and depth. And in this video lecture, this is the second video lecture of the class 11th physics. I am A.D. Borude, and in this video lecture we discuss about the gravitational field. Gravitational field. What is the gravitational field? Gravitational field means space around the planet where the force can be experienced. Gravitational force can be experienced by the another body. So this is the gravitational field, and it is expressed in terms of the intensity of gravitational field. Gravitational field intensity, it is a force per unit mass, force per unit mass of a body. So gravitational field intensity, it is denoted by the E, the force experienced per unit mass. So unit force is a force, unit of the force we can write the unit, the force is a Newton, or this is a mass per kg, force experienced per unit mass, or dimension of this quantity. Dimension of this quantity, force is expressed in terms of the mass into the acceleration. Mass is a m raised to 1, L raised to 1 for the acceleration, L raised to 1 and T raised to minus 2, or divide by the mass ka, this is the m. The dimension, this is the L raised to 1, T raised to minus 2. This is the dimension of a intensity of a gravitational field. Then gravitational potential energy. Next is the gravitational potential energy. Gravitational potential energy. So gravitational potential energy means energy possessed by the body in the gravitational field of the planet, gravitational field of the earth. Energy possessed by the body in the gravitational field of the earth. This known as a gravitational, or energy due to the position of the body in the gravitational field of the earth, this known as a gravitational potential energy. Or what is the gravitational field? Intensity of the gravitational field or gravitational potential energy. Energy of a body due to its position, or energy possessed by the body due to its position in the gravitational field of a earth, this is known as a gravitational potential energy. And it is calculated, you have find out, this is the amount of work done, this is the amount of work done to bring the body from infinity to that point in a earth gravitational field, and this is the amount of work done to bring the body from the infinity to that point in a earth gravitational field. This known as a gravitational potential energy. It is a method of the calculating it. Okay. Consider a earth is a sphere of a center O. Mass of this is a m. Mass of earth m. Radius of the earth radius of a earth is a r. Radius is a r, and the p is a point. This is the radius r. यहाँ से this is the O to ये r, and p is a point at a distance x from the center of the earth. This is the x distance. So this is the amount of work done, or consider the body as at a point A, and this point A is at a distance r from the point A is at a distance. Okay, you can write this is the r, p this is the r distance, and point A is at a distance x from the center of the earth, x from the center of the earth. Or so this at a point A, the force experience, the force of body, mass, body का mass कितना है, small m. Then force experience body, कौन सा force? The gravitational force. कौन सा? Gravitational force. This is F is equal to, according to the Newton's law of gravitation, capital M, mass of the earth capital M, and this small m divided by ये कितना है? तो ये डिस्टेंस जो है सेंटर ऑफ अर्थ से, दिस इज द एक्स स्क्वायर. दिस इज द फोर्स एक्सपीरियंस बाय द बॉडी व्हेन प्लेस एट ए पॉइंट ए विच इज ए एक्स डिस्टेंस फ्रॉम द सेंटर ऑफ द अर्थ. सेंटर ऑफ अर्थ से इतना रखने के बाद ये इतना फोर्स एक्सपीरियंस करता है. एंड अनदर पॉइंट इज अ वेरी क्लोज, इट इज ए बी, एंड डिस्टेंस इज ए डी एक्स. To move the body, to bring the body from point A to B, to move the body from point A to B, amount of work done, this is the amount of work done, this is a dW equal to F into this is displacement कितना किया A to B, it is a dx. So this is small amount of work done, dW equal to F कितना है, तो this is a F equal to this is a gravitational constant capital G capital M small m divided by x square into dx. This is the small amount of work done to move the body A to B. A to B मूव करने में स्मॉल डिस्प्लेसमेंट dx मूव करने, दिस इज द वर्क डन. देन वी कैन फाइंड आउट द टोटल वर्क डन, टोटल वर्क डन टू ब्रिंग बॉडी फ्रॉम कहाँ से, इन्फिनिटी टू द पॉइंट, infinity to the point on surface of earth, infinity to the point surface of earth at r, center से कितना दूर, r distance. So amount of work done dw equal to integration infinity से, limit is taking infinity से r तक लाना है, to bring the body from infinity to r, या r, yes, we can take this small r, infinity to at a distance r, earth at point P at a distance r. So infinity to r, ये point लाना है from the infinity to this point. So total amount of work done equal to G capital M small m divided by x square dx. So integration of dw is a w, and this G capital M mass of the small body, all they are constant. That's varying the distance is a change. X क्या होता है, ये vary होता है. So this is a G capital M small m, this is the constant. Integration of a 1 by x square dx, our limit infinity to r, or integration of a x raised to n dx equal to x raised to n plus 1 divided by n plus 1. This is the formula, और ये लिमिट है, द कांस्टेंट नहीं है. तो ऐसा ही इसी के लिए इंटीग्रेशन लेंगे, ओमेगा इक्वल टू जी कैपिटल एम द स्मॉल एम, और दिस इक्वल टू इंटीग्रेशन एक्स रेस टू minus 2 dx और लिमिट इन्फिनिटी टू r, और इंटीग्रेशन ऑफ दिस टर्म, इसका इंटीग्रेशन लेंगे m डिवाइड बाई m, इसका इंटीग्रेशन x रेस टू, ये फॉर्मूला से n कितना है माइनस 2 प्लस 1 डिवाइड बाई माइनस 2 प्लस 1 और लिमिट अपर r और लोअर इन्फिनिटी, इस तरीके से। अब यहाँ देखो दिए वर्क डन इक्वल टू g कैपिटल M स्मॉल m, और इसका सिंप्लीफाई कर दो x रेस टू माइनस 1 डिवाइड बाई माइनस 1 और लिमिट इसका क्या आएगा इन्फिनिटी टू r। वर्क डन इक्वल टू g कैपिटल M द स्मॉल, और ये आएगा माइनस इसका ये, और दिस इज द 1 बाई x और लिमिट इन्फिनिटी टू r। So work done equal to minus g capital M this is small m, और लिमिट इसका 1 by r minus lower limit, upper minus lower limit. So work done equal to minus g capital M the small m divided by r, and this is the work done is stored, or work done is the same as a potential energy. So potential energy equal to minus g capital M small m divided by r. This is the potential energy of a body, or this is the potential energy of a body, the amount of work done to bring the body from infinity to the point P. This is the potential energy. And gravitational potential, gravitational potential V is equal to, this is energy, gravitational energy per unit this mass, gravitational energy per unit mass, this is या work done, energy बोलने से पूछे work done per unit mass. So work done कितना, V equal to work done again minus g capital M the small m divided by m, this will get cancelled. The gravitational potential gm capital M divided by क्या आएगा r. This is the gravitational potential. तो ये समझ में आया। तो ग्रेविटेशनल फील्ड क्या होते थे, स्पेस अराउंड द planet or earth where gravitational force can be experienced, this is known as a gravitational field. Or the gravitational potential energy is the energy possessed by the body due to the position of the body in the gravitational field of a earth, this is known as a gravitational energy. And this is a calculated the amount of work done to bring the body from infinity to that particular point P, infinity to that point P. This is the work done in the gravitational field of a earth. So this is calculated in this way, और ये हो गया gravitational potential energy. Then next topic is a escape velocity. Okay. Escape velocity. Escape velocity. This is the amount of or minimum velocity. This is the minimum velocity required to escape from earth gravitational field, earth gravitational field. To escape from the earth, minimum velocity is required to escape from the earth gravitational field. This is known as a escape velocity. Or escape velocity, it is calculated by using the expression that escape velocity, consider a earth is a sphere of a mass is a m, center is a o, and radius is a r. So this is equal to, कहाँ से minimum velocity is required to escape from the earth gravitational field. So this suppose this body is at any point P which is a x distance from the center. कहाँ से? यहाँ से x distance from the center, यहाँ से x distance पर है. m is the mass of the body. m is a mass of the body, small m, mass of a body at point कहाँ है? P पर है. And capital M is a mass of a earth, mass of earth. R is a radius of earth, earth का radius है. And OP equal to this, OP is a distance equal to x. Then force experienced by this body due to this earth mass m equal to capital G, capital M, small m divided by x square. This is put equation number 1. And force experienced by this body, F is equal to this. Suppose consider this body, it is a displaced from the P to A with the dx, the amount of work done to move the body P to A, this is a small amount of work done to move body from A to P to A. So amount of work done is a dW equal to F into dx. This is a displacement kitna? dx. So amount of work done. So dW this equal to F G capital M, the small m divided by x square into dx. This is the small amount of work done to move the body from point P to A move करने के लिए इतना work done है. So this, what is the total work done? Then total work done to move the body total work done to move body from the surface of earth is r to infinity. So total work done dW equal to, taking the limit, कहाँ से जाना है? Surface of earth से infinity जाना है, तो r to infinity. So the work done G capital M small m divided by x square into dx. This is the total amount of work done to move the body from the surface of earth to the infinity to escape from the earth gravitational field. So dW, this is the W equal to G capital M small m, all these are the constant. Integration 1 by x square dx और लिमिट r to infinity. तो इसका इंटीग्रेशन कहाँ कैसे निकालना, ये हमने जस्ट आगे पहले डेरिवेशन में बताया. x इंटीग्रेशन x रेस टू n dx इक्वल टू x रेस टू n प्लस 1 डिवाइड बाई n प्लस 1. सो dw इक्वल टू g कैपिटल m और इंटीग्रेशन ऑफ दिस इज x रेस टू कितना रेस टू -2 प्लस 1 -2 प्लस 1 और इसका लिमिट r टू this is infinity. So this is work done, this equal to, अब ये आएगा माइनस G कैपिटल M स्मॉल m और 1 by x infinity to r. तो वर्क डन इक्वल टू माइनस G कैपिटल M स्मॉल m और अपर लिमिट 1 by infinity माइनस लोअर लिमिट 1 by r. सो वर्क डन इक्वल टू ये तो जीरो टर्म बनेगा और ये हो जाएगा प्लस G कैपिटल M स्मॉल m डिवाइड बाई r. दिस इज द अमाउंट ऑफ वर्क डन टू मूव द बॉडी फ्रॉम r to infinity. And this work done, this is the work done is a same as a और दिस वर्क डन इज ए सेम एज ए काइनेटिक एनर्जी। और जैसे बॉडी यहाँ से मूव करेगा तो किससे, इट इज़ अ मोमेंट, सो वर्क डन इज ए, और काइनेटिक एनर्जी ऑफ ए बॉडी, काइनेटिक एनर्जी ऑफ ए बॉडी is a due to work done. The work done is the same as a kinetic energy. So this is the half m into ve. Ve मतलब this is the escape velocity, ve square. This is the kinetic energy equal to g capital M, this small m divided by r. This is the mass of body. This also mass of body. This get cancelled. तो V E square equal to 2 times G capital M divided by R. तो V E equal to अंडर रूट, अगर ये स्क्वायर निकालेंगे तो अंडर रूट रहेगा 2 G M divided by R, 2 G M divided by R. This is the orbital velocity. This is the orbital velocity, or this we can write in another form. जैसे g इक्वल टू जी एम डिवाइड बाई आर स्क्वायर, दिस इज मास ऑफ अर्थ ग्रेविटी, ये फॉर्मूला। तो ये यूज़ करके हम जी एम का वैल्यू इसमें रखेंगे तो g इंटू आएगा आर स्क्वायर। तो ये जब वैल्यू इसमें रखेंगे तो ऑर्बिटल वेलोसिटी का फॉर्मूला बनेगा अंडर रूट 2 टाइम्स g इंटू आर स्क्वायर डिवाइड बाई आर, 1 आर गेट कैंसिल, तो वी ई इक्वल टू अंडर रूट 2g इंटू आर. So this is the another expression for the orbital velocity. Orbital velocity equal to under root 2 times g into r. When we substitute this value, ve equal to under root 2, g का value 9.8 into r 6.4 into 10 raised to 6. This is the radius of the earth. Then v suffix e, the orbital velocity of the body. This equal to this is the 11.2 into 10 raised to 3 velocity. This is a meter per second, or orbital velocity VE, this equal to 11.2 kilometer per second. So this means to escape the any body from the earth gravitational field, it needs the escape velocity 11.2 kilometer पर सेकंड. इतना वेलोसिटी से अगर बॉडी अर्थ से ग्रेविटेशन से अगर ये पेन मुझे एस्केप करना है तो इतना वेलोसिटी से इसको प्रोजेक्ट करना पड़ेगा 11.2 किलोमीटर पर सेकंड. देन बॉडी विल बी एस्केप फ्रॉम द अर्थ ग्रेविटेशनल फील्ड. तो आसान है, डेरिवेशन इज ए सेम और इट इज आस्क फॉर द 3 मास, हमेशा 3 मास के लिए आता है. व्हाट इज द एस्केप वेलोसिटी? मिनिमम वेलोसिटी इज रिक्वायर्ड टू एस्केप द बॉडी फ्रॉम द अर्थ ग्रेविटेशनल फील्ड एंड इट इज कैलकुलेटेड इन दिस वे. ये जैसा वर्कआउट हो गया. अब दूसरा टॉपिक पढ़ेंगे इसमें, ऑर्बिटल वेलोसिटी. ऑर्बिटल वेलोसिटी. Orbital velocity means this velocity is required to keep the body in a earth orbit or in its a stationary orbit. This is the orbital velocity. The velocity is required to keep the body in its earth orbit. Yeah, this amount of velocity required to keep the satellite in a earth orbit, or to move the satellite in a earth orbit. This is known as a orbital velocity, or this is the minimum again velocity required. Minimum velocity is required to put the satellite in a earth orbit. This known as a orbital velocity in a earth orbit. This known as a orbital velocity. And this orbital velocity is calculated. Consider the earth is a sphere of mass. Earth is a sphere. The mass of the earth is m and radius is a r. This is the O is the center of Earth, and satellite which we have to put in a Earth orbit with is a height. Suppose the Earth orbit, it is a height is a h. This is h is a height and r is a radius. So total this is equal to r plus h. This is equal to r plus h is a Earth's orbit. Then when this is the at an h height from the Earth orbit, it is an Earth orbit height h. Then force equal to force at this point. यहाँ कितना force? तो force equal to G capital M small m. This is the mass of the satellite. मैंने mention नहीं किया. This is the satellite mass of the small m is the mass of a satellite. इसका सैटेलाइट का मास. देन फोर्स इक्वल टू क्या आएगा? r प्लस h इसका स्क्वायर. पुट दिस इज द इक्वेशन 1. दिस इज द ग्रेविटेशनल फोर्स ऑफ अट्रैक्शन बिटवीन अर्थ एंड सैटेलाइट एट एंड दिस पॉइंट P. ये पॉइंट पे इतना है क्योंकि इसका मास कितना m है. कैपिटल M इज द मास ऑफ द अर्थ. देन फोर्स ऑफ अट्रैक्शन फ्रॉम देयर सेंटर इट इज F इज इक्वल टू G capital M small m divided by r plus h square. When a satellite is revolving around the earth, it has a centripetal force. The centripetal force equal to, this is the force of attraction, centripetal force of a satellite revolving around the earth orbit equal to, this equal to m into v orbital, तो vo यूज करेंगे, m vo square divide by r plus h. m v square divided by r. This is the centripetal force. And to keep the satellite in earth orbit, to keep satellite in earth orbit, this is the centripetal force, and this centripetal force and gravitational force of attraction, centripetal force and gravitational force of attraction is equal, then satellite will be in a earth orbit. So we can equate this to this m into v naught square divided by r plus h equal to g capital M small m divided by r plus h square. This one get cancelled, or mass is also get cancelled. So this equal to remaining terms vo square, this orbital velocity, this equal to g m, this is the mass of earth, we can write this capital word, r plus h x square, तो इसके साथ कैंसिल हो गया तो ये टर्म बच गया. मतलब vo orbital velocity equal to under root g capital M divided by r plus h. This is it. And we can write in another form, g is equal to g m divided by r square. This is the r plus h इसका square. So g m equal to g into r plus h इसका square. You can write this. We can write this in another form. This equal to r plus h, or r plus h. This is approximately equal to, you can take this is r, because r is a very less than this h is a very small height as compared to the radius. Then we can write this vo equal to under root gm की जगह क्या लिखना है, तो g r plus h उसका स्क्वायर डिवाइड बाई आर प्लस एच, और ये छोटा है, दिस विल गेट कैंसल, तो वी वाई इक्वल टू दिस वैल्यू यू कैन राइट अंडर रूट जी आर प्लस एच, एंड दिस इज आर, एच इज ए वेरी स्मॉल एज कंपेयर टू आर, सो द वी ओ इक्वल टू अंडर रूट क्या आएगा जी इंटू आर। सो वी ओ इक्वल टू, अगर इसका वैल्यूज रखते हैं 9.8, जी का वैल्यू ग्रेविटी and radius of r 6.4 into 10 raised to 6, then VO this value will become 11.2 kilometer per second. This is equal to some 11 point, not 11 point, this is the 7.92 kilometer per second, kilometer per second. So this is the orbital velocity. To keep the satellite in earth orbit, the minimum velocity 7.92 kilometer per second is required to keep the satellite in a earth orbit. Okay, then when we compare this the equation, अगर ये देखेंगे तो ये independent on the किस factor पे depend करता है, orbital velocity independent on mass of a satellite, and mass of the satellite, it is independent on the mass and mass of the satellite, but it depends on the mass of the planet, depends on the mass of the planet, and mass of the planet is a capital M. Independent on the mass of the satellite, but it depends on the मास ऑफ द प्लैनेट, प्लैनेट से डिपेंड करता है, लेकिन सैटेलाइट का छोटा मास यम है उससे इंडिपेंडेंट। लेकिन ऑर्बिटल वेलोसिटी क्या होगा, डिक्रीज होगा व्हेन वी इंक्रीज द हाइट ऑफ द ऑर्बिट, और ऑर्बिट अगर बढ़ेगा तो ऑर्बिटल वेलोसिटी डिक्रीज होगा। सो दिस इज ऑल अबाउट द टुडेज क्लास। तो वी डिस्कस अबाउट द व्हाट इज द ग्रेविटेशनल फील्ड, ग्रेविटेशनल फील्ड क्या होता है, उसके बाद ग्रेविटेशनल पोटेंशियल एनर्जी, और उसके बाद एस्केप वेलोसिटी और ऑर्बिटल वेलोसिटी के बारे में पढ़ा। तो ये आई होप दिस यू अंडरस्टूड इट प्रॉपरली, और थैंक यू, हैव ए गुड डे।